What if I told you there's an object in space so powerful it can stop time, bend light, and erase entire stars from existence, and we still don't fully understand it? From devouring galaxies to storing secrets of the universe, black holes aren't just science fiction, they're science fact. And today, we're going to pull you straight into their gravitational grip. Welcome to the Top 10 Facts Club, where, today, we're falling headfirst into the most mind-bending mysteries of black holes. These aren't just cosmic vacuum cleaners, they're gateways to the weirdest physics in the universe. If you think black holes are just empty space, think again. Like, share, and subscribe, because these facts are going to warp your brain harder than space-time near a singularity. 10. Black holes can slow down time. Want to travel to the future without a time machine? Get close to a black hole. According to Einstein's general theory of relativity, gravity isn't just a force, it's a curvature of space-time. The stronger the gravity, the slower time flows. Near a black hole's event horizon, gravity becomes so intense that time for an outside observer appears to stop entirely. In fact, if you could hover near the event horizon without being pulled in, which is basically impossible, decades or even centuries could pass in the universe, while mere minutes tick by for you. This isn't just theory, it's been confirmed through GPS satellites and atomic clocks in different gravitational fields. Black holes are natural time machines, but only in one direction, forward. Movies like Interstellar showcase this concept perfectly when Cooper and his crew spent minutes on a high-gravity planet near a black hole. Years passed for those left behind. The fact that gravity can manipulate time like this isn't just sci-fi imagination, it's real physics with real consequences, and it reshapes how we think about time as a constant. It's not. Black holes don't just warp time, they prove it's never been what we thought. 9. They're not really holes. Black holes aren't holes at all. They're the densest objects in the universe disguised by a bad name. It conjures up images of bottomless pits or cosmic drains sucking everything into oblivion. But black holes aren't empty spaces or tunnels. They're objects, extremely dense, compact, and terrifyingly real objects. At the center is a singularity, a point of infinite density where the laws of physics break down. Surrounding that is the event horizon, the invisible boundary where escape becomes impossible. Imagine cramming the mass of our sun into a sphere just a few kilometers across. That's how dense black holes are. It's not the hole that makes them dangerous, it's the gravity. They warp the geometry of space and time, and their effects can stretch light, twist magnetic fields, and spin nearby matter at nearly light speed. They are engines of extreme physics, not cosmic vacuum cleaners, but nuclear furnaces fused with gravity wells. 8. Black holes can get hungry and messy. When black holes feed, it's not a quiet dinner, it's a cosmic feeding frenzy. Gas, dust, stars, even entire solar systems can be drawn into their grasp. As matter spirals toward the event horizon, it forms an accretion disk, superheated by friction and gravitational compression. These disks can outshine entire galaxies, blasting radiation across the cosmos. It's one of the brightest phenomena in the universe, ironically emitted from one of the darkest places. Sometimes, black holes get greedy and swallow stars whole. During tidal disruption events, a star gets torn apart into spaghetti-like strands, a process dubbed spaghettification. The intense tidal forces stretch the star into a thin stream before it's consumed. Yet, even black holes have limits. Some of the matter escapes, shot out from the poles in relativistic jets, beams of particles moving at nearly light speed. These jets can span hundreds of thousands of light years, influencing galaxy formation and regulating star birth across vast regions. These monsters don't just swallow, they reshape galaxies with every bite. 7. There's a supermassive black hole at the center of our galaxy. Right now, in the heart of the Milky Way, sits a monster, Sagittarius A star. It's a supermassive black hole, over 4 million times the mass of our Sun. Though invisible to the naked eye, its gravitational influence reveals its presence. Stars in its vicinity orbit at incredible speeds, some completing orbits in just 16 years, on paths curved by a gravity so intense It rivals the strongest magnets in the universe. In 2022, the Event Horizon Telescope collaboration gave us the first image of Sagittarius A star. It was a scientific breakthrough that confirmed decades of suspicion and theoretical models. What's more astounding is that nearly every large galaxy seems to have a supermassive black hole at its core. Are these behemoths the engines of galaxy formation or the leftovers? No one knows for sure, but their presence suggests that they play a crucial role in galactic evolution, potentially acting like regulators that shape star formation. They might be galactic architects. 6. They can evaporate. Despite their reputation as eternal prisons of matter, black holes may not live forever. In 1974, Stephen Hawking rocked the physics world by proposing that black holes emit radiation, now called Hawking radiation. This radiation comes from quantum fluctuations near the event horizon, where particle-antiparticle pairs form. Occasionally, one particle falls into the black hole while the other escapes, effectively stealing energy from the black hole and causing it to lose mass. Over immense periods of time, especially for smaller black holes, this process could lead to complete evaporation. A black hole with the mass of a mountain could vanish in a flash of gamma rays within seconds. Stellar or supermassive black holes would take longer than the age of the universe. But the theory upends everything we thought we knew about them. Instead of infinite traps, they become temporary storage, albeit ones with extremely long expiration dates. But what happens to the information that fell in? That question still haunts physicists. Turns out even death traps can disappear, but the mystery only deepens. 5. Black holes may be portals. What if black holes aren't the end, but shortcuts to somewhere else? Some solutions to Einstein's equations allow for something called wormholes, tunnels through space-time. If these structures exist and remain stable, they could connect distant parts of the universe or even different timelines. Some believe black holes could be entrances to these wormholes, with theoretical white holes acting as the exits. While there's no evidence of white holes and most wormholes would collapse instantly or require exotic matter to stay open, the math works on paper. Movies like Interstellar dramatize this concept, but physicists take it seriously too. Could black holes be nature's version of a hyperloop? A galactic subway? Possibly. But until we can probe past the event horizon, it's all speculation. Still, the idea that these terrifying objects might actually lead somewhere rather than to a one-way doom is part of what makes them so fascinating. They're not just destroyers. They might be cosmic architects. 4. They can collide and send ripples through the universe. When two black holes collide, the resulting event sends shock waves, gravitational waves, through the very fabric of space-time. These ripples were first predicted by Einstein, but remained unconfirmed until 2015, when the LIGO detector caught the faint echoes of a black hole merger over 1 billion light-years away. Since then, dozens of such collisions have been detected, each telling a story of ancient cosmic violence. Gravitational waves carry incredible amounts of information, mass, spin, even the age of the black holes involved. The power released in the final milliseconds of these mergers often exceeds that of all stars in the universe combined. These events not only confirm theories, they open entirely new observational windows. These collisions don't just shake space, they let us hear the universe's deepest secrets. It's like adding hearing to a species that could only see. 3. Black holes can store information, but we don't know how. Here's the black hole information paradox. Quantum mechanics insists that information about a physical system can't be destroyed. But general relativity says anything that falls into a black hole vanishes. Information and all. So which is it? Some scientists argue that the information isn't lost, but encoded in the subtle quantum fluctuations at the event horizon. This gave rise to the holographic principle, which suggests that all the information about what falls into a black hole could be stored on its surface, like a 3D object projected from a 2D surface. Others argue that information may eventually leak out via Hawking radiation. Still others believe we need a whole new theory of quantum gravity to solve this puzzle. No matter the answer, this paradox touches the core of physics. It's not just about black holes, it's about whether reality itself obeys predictable laws. 2. They can form from collapsing stars or in the early universe. Most black holes are born from death. When a massive star runs out of fuel, its core collapses, triggering a supernova explosion. If the remaining core is dense enough, gravity takes over, crushing it into a black hole. These are called stellar mass black holes, and they litter the galaxy like cosmic graves. But there's another, more mysterious kind: primordial black holes. These may have formed moments after the Big Bang, when the universe was a hot, dense soup. Quantum fluctuations could have created pockets of matter dense enough to collapse into black holes. Unlike their larger cousins, these would be tiny, maybe the size of an atom, but with the mass of a mountain. Some scientists even suggest that dark matter might be made of these ancient relics. If so, they're all around us, and we've just never noticed. 1. We took a picture of one, and it changed everything. In April 2019, the impossible became real. Scientists unveiled the first ever image of a black hole located in the galaxy M87, captured by the Event Horizon Telescope. This snapshot showed a glowing orange ring, a shadow cast by the event horizon against the background radiation of space. This was more than just an image. It was a confirmation that Einstein's theory of general relativity holds true even under the most extreme conditions. The shape, size, and structure of the shadow matched predictions precisely. To get the shot, scientists coordinated 8 radio telescopes across the globe, forming a planet-sized interferometer. It was a milestone in science, a true moon landing moment for astrophysics, and it reminded us that even the darkest corners of the universe can be brought into the light. Black holes don't just challenge our understanding of the cosmos, they shatter it. From time distortion to quantum mysteries, they're cosmic laboratories wrapped in darkness. Which black hole fact messed with your brain the most? Drop your favorite in the comments. And if this video warped your sense of reality, smash that like button and subscribe for more deep dives into the unknown. Until next time, keep questioning everything, especially the things that bend light.